Hi, welcome back. In part 2 of our session on using Cluster API provider vSphere, we're going to walk through the process of using the management cluster that we created in part 1 of this series to create workload clusters in our VMC environment. So first, let's do kind of a quick recap of what we accomplished in the last session. We created a Bootstrap cluster on our local jump box. We use that Bootstrap cluster to then create our CapV management cluster in our VMC EMEA environment. So the current state of our architecture, we have a single node Kubernetes cluster running in our VMC environment that is going to act as our management cluster for our CapV deployment. So the next thing we're going to do is use the same manifest Docker image that we used in part 1 of our series to automate the creation of manifests for a workload cluster. Now, we don't have to use this image to create these manifests and the scaffolding for our cluster, but like I said in the previous session, it just makes this process a lot easier because these files have a lot of information in them, and if we can automate that process and simplify it in any way, we usually want to take advantage of that. So again, we use that same image with the Docker run command to use the environment variables file that we defined in the previous section that lists environment variables such as the vSphere username and password, the vCenter location in our VMC environment, data stores, the template to use for the virtual machines, et cetera, et cetera. And this time when we run the Docker command, we're going to use the CapV EMEA workload cluster name. So when we run that Docker command, we see all of our output is now created in the CapV EMEA workload cluster. So all the files within that folder, they look exactly the same: addon.yaml, cluster.yaml, control plane.yaml, as our previous example for our management cluster, but they're in a different folder under the workload cluster name. So now that we've got our manifest created, as the developer actually can simply use kubectl to deploy their workload cluster. But first, we need to make sure that we are using and interacting with the workload cluster via kubectl. So kubectl looks for a kube config file that gives the tool information about where the cluster is located and how it can authenticate to the cluster and access information and things of that nature. So the first thing we'll want to do is export the kube config file variable to give it the kube config location for our management cluster, because we want to use kubectl to pass all these YAML files to the management cluster, so then the management cluster then can create our workload cluster. So after we've exported that config file, we can use kubectl get nodes to query information about our cluster. And if we look at the vCenter UI in our VMC environment, we can see that this is our IP address for our Kubernetes management node, and we can compare that with what we see in the vCenter UI to make sure we're in the right place if there was confusion. So now we're ready to create the workload cluster. The first thing we need to do is actually create the cluster object. So we went through in detail in the Cluster API overview section about what the cluster object is, but it's essentially just a quote-unquote container for the cluster that contains information like IP segment to use, the name of the cluster, things like that. So as we saw from the animation, we passed the YAML file over to the management cluster from the jump box. The management cluster then created the cluster object in VMC. So we haven't created any virtual machines yet. We've just created that quote-unquote container or that cluster object in our VMC environment. So now we're ready to create the master node or the control plane. So we use kubectl to pass the control plane YAML file that was created by the Docker manifest earlier to the management cluster. And so the YAML file is passed over to the management cluster. The management cluster then creates a virtual machine to serve as the control plane for our workload cluster and instantiates it with the bootstrap, the kubeadm and init commands. And now we have a functional master node for our workload cluster. So if we look at our vSphere UI, we can see that we have our CAP VMEA workload control plane virtual machine that is spun up in VMC to serve as our control plane node. So we're good to go there. So when we created our manifest for our workload cluster for the worker nodes, it automatically assigns replicas to 1. So it only creates a single worker node in our cluster. So we want a little more compute power, so we're going to change that to 3. So we're going to edit that file and change the replicas from 1 to 3. After we do that, we're ready to create that machine deployment, which will serve as our worker nodes for the cluster. So we use kubectl to pass that machine deployment YAML to our management cluster, and we get information back from the API server of the management cluster that there's a machine, a kubeadm config template that has been created for those worker nodes, a machine deployment that's been created to control the worker nodes as well. So if we look at the diagram, we pass the YAML file over to the management cluster. The CRDs and then the controllers on the management cluster reaches out to the vSphere infrastructure to create the virtual machine, instantiate them as Kubernetes worker nodes, and connect them into the master node. And if we look in our vCenter UI, we can see our new workload VMs have been created and added into the environment. So now we can use the management cluster to spit back and give us information about these CRDs or custom resource definitions that we've deployed to serve as our workload cluster. So if we use kubectl to get cluster machine deployment machines, this is what we get back from the management cluster. So the management cluster is aware and is the management kind of plane for this workload cluster and then all workload clusters going forward. So if we look at the clusters that have been provisioned, we see both the workload cluster that we just provisioned as well as the management cluster. So the management cluster is aware of itself as a cluster object type in this environment. And we only have one machine deployment because our management cluster doesn't have any worker nodes. It's just there as a single master to orchestrate the deployment of additional worker nodes. And if we look at machines, these are essentially all the virtual machines that we have deployed in VMC that comprise our environment currently. So we have our management control plane VM, we have our workload control plane VM or our workload master, as well as our 3 worker nodes that are all of them are in the running state, which is really good. So we're really happy with what we see so far. But let's say we want to scale our cluster to 5 worker nodes. So we want additional worker nodes. We need more kind of compute power for our cluster than we originally thought. So we can use the management cluster and we can use kubectl to actually edit the machine deployment that we observed previously in the kubectl output and change the replicas to 5. So if we look at the diagram, okay, we make that change to our deployment. The management cluster then spins up 2 additional worker nodes and instantiates them as worker nodes and adds them under the control of the control plane. If we look at our vSphere UI, we can see we've got 2 additional virtual machines provisioned to support that cluster. So that really is powerful as far as infrastructure management and automation for provisioning these clusters. We don't have to communicate with our VI admin to manually spin up virtual machines. We don't even have to log on to the OS of these worker nodes because all of this is automated for us by the CAP-V management cluster, which is really powerful. So now we're actually ready to start to interact with the workload cluster itself. So the first thing we need to do is retrieve the workload cluster's config file. So when we perform kubectl commands now, we want to communicate with the workload cluster, not the management cluster as we've been doing previously. So the config file for workload clusters are stored as secrets on the management cluster. So we talked about secrets in our Kubernetes architecture overview, but these are just files that store sensitive information that are base 64 encoded. So anytime we create a workload cluster, our management cluster will house the secret for our config file to access that cluster. So if we do kubectl get secrets, which is we're still talking to the management cluster, we can see we have a cap vMia workload kube config secret. So we need to decode that. So we'll use this command to decode that secret and export it to our directory where we're storing all the rest of the information for our workload cluster. And now we're ready to export the location of that kubeconfig file to the kubeconfig environment variable. So when kubectl is querying the API server, we're talking to the API server of the workload control plane instead of the management cluster control plane. So now we can use kubectl to gather information about our workload cluster. So when we do kubectl get nodes now, we get our workload cluster control plane and 5 worker nodes. So if we look at the diagram, we enter kubectl get nodes and we're actually communicating with the workload cluster. But if we have a look, we are in a not ready state for all of our nodes, which is not good. So we need to remedy that. What's happening is we have not deployed any sort of container network interface, which is responsible for providing the networking for our nodes and pods in our environment. So if you remember back to our Docker command where we created scaffolding for our clusters, there was an addon.yaml file that was created that will allow us to deploy Calico, which is a CNI provider, to our cluster to spin networking up. You don't have to use Calico. You can use any CNI of your choosing. capv deploys a YAML file that creates Calico resources by default, but you can use any CNI that you want. In this example, we're going to deploy the addon.yaml to create all the resources needed to spin up our Calico container network interface. Now, we can look at kubectl get nodes and verify that all of our applications are in the ready state, or excuse me, all of our nodes are in the ready state, so we're ready to deploy applications to our workloads. So that's an overview for deploying workload clusters, and we talked a little bit about kind of the power of automating the provisioning of the infrastructure to support these workload clusters. But if you can kind of iterate out to what this might look like at scale, our developers can pass YAML files to the management clusters and create X amount of workload clusters. So if they're within the limits of their resource pool in the VMC environment, this gives our developers kind of infinite power within their within the constraints set by the admin, the VI admin, to create these workload clusters as needed. So the developers can use their familiar Kubernetes primitives to create this infrastructure, and they don't have to wait for the VI admin to provision kind of the traditional virtualization infrastructure that supports the clusters. So that concludes our session on part 2 of using Cluster API to deploy our workload cluster. In the next session, we're actually going to walk through an example application that we're going to deploy on top of one of our workload clusters.